Welcome to Approach to ABGs Part 6. Here we're going to give some numerical examples of osis and emia. I'm going to put this equation at the top, the standard way of writing a blood gas, just to remind you. This example, we're going to have a pH of 7.21, a PCO2 of 60, and a bicarb of 24. We're going to put our little equation here, and just to reorient you, the numbers, I just want to point out something. So the pH relates to the hydrogen ion concentration, and just the way the equation is written and the standard format of the ABG, I don't want you to be confused because there's a bit of a crisscross here. The PCO2 shows up in the second position when we write out an ABG, but it's at the far right of the equation. And the bicarb is at the end of the way we write an ABG, but it's in the middle of the equation. So I just wanted to point this out so that it didn't cause confusion for anybody. So let's go forward and see if we can analyze all three values of this ABG. And remember, we're always going to determine the osis before we determine the emia. So here we've got 722, PCO2 of 60, a bicarb of 24. As a reminder, we can see what the normal values are, 7.40, PCO2 normal value is 40, bicarb normal value is 24. So let's analyze the osis. And the first thing we're going to do is look at the PCO2, and you can see that the PCO2 is elevated. So with that, we're going to expect this chemical equation to shift to the left. This is going to increase the hydrogen ion concentration, and we have respiratory acidosis with acidemia. And when we look at the blood gas, we can see PCO2 is elevated at 60, and as we expected, the pH is on the acid side of normal. It is reduced at 7.22. So this all makes sense. And we're not going to analyze the bicarb because it's completely normal. It has not gone up or down. Therefore, it will not contribute to shifting the equation to the left or to the right. In this example, we only have one osis process, which is a respiratory process. Here's a second example, pH 7.28, PCO2 of 40, and a bicarb of 18. So the PCO2 of 40 is normal. There's nothing to analyze there. The bicarb is low. This is going to generate a little bit of a vacuum on the left side of the equation, so it's going to shift left, which will increase the hydrogen ion concentration. And this is going to give us a metabolic acidosis because the bicarb is the primary process here, so it's going to be metabolic acidosis with acidemia because the pH is again on the acidic side of 7.40. Here's our third example, a pH of 7.56, a PCO2 of 28, and a bicarb of 24. We'll analyze the CO2 first. 28 is obviously less than 40, so the PCO2 is down. This creates a little bit of a vacuum on the right side, so the equation will shift to the right. This will consume hydrogen. The hydrogen ion concentration will be down, which gives us an alkalosis process. And because CO2 is what is driving this process, we're going to say this is a respiratory alkalosis with alkalemia. And our final example, looking at numerical values, we have a pH of 7.53, PCO2 of 40, and a bicarb of 32. Well, a bicarb of PCO2 is normal, so there's nothing to do there. A bicarb of 32, pardon me, the arrows came in the wrong way. Bicarb is up. This is going to shift to the right. That's going to consume hydrogen. The hydrogen will drop, and we're going to have a metabolic alkalosis with alkalemia. These are all examples of single abnormalities, and you might think it's a bit redundant that I'm saying respiratory acidosis with acidemia instead of simply saying respiratory acidosis. And you're right, it is actually quite redundant when there's only one process. But we're going to get into some examples where there are multiple osis processes and it becomes a little bit more complex, and you're going to have to balance things out, and the pH sometimes is hard to predict. So for now, we're just going to keep the osis and the emia processes separate from each other just to help increase your understanding. If this seems a little bit too simple, I promise it gets a little bit more complex in the upcoming podcasts.